What's up? I'm Vin, and I'm going to show how to determine if equations define functions. So we have 5 questions, and we want to see if these equations can define y as a function of x. So first up here, we have this equation over here. And what we're going to try to do for all of these questions is solve for y and see that we get something that can determine a function. So I'll start here by subtracting 3x on both sides. And on the left side, we have 3x minus 3x canceling. And then we have negative 5y equals negative 3x and then plus 7. And from here, we just divide everything by negative 5. And this is going to give us, at the end, we have y equals, and we're going to have negative 3 over negative 5 is positive 3/5. And then we have x, and then 7 over negative 5, I could just say is minus 7 over 5. So this equation is linear, and a linear graph can determine a function of x. So I can rename this. I'll call this, let's say, f of x. I'll say f of x, our function, is 3/5 x, and then minus 7/5. If I were to sketch this, on the side here, we have a positive slope and a negative y-intercept. So that means that our function, if I were to just sketch it out, would look something kind of like this, not necessarily drawn to scale. But here's a sketch. And if you want to determine if your graph determines a function of x, you could run the vertical line test. And if we draw vertical lines through this line at any point, notice that it's only going to touch the line at one location. So for question 1, we can say that this equation does determine y as a function of x. Question 2, we have this equation, and I'll just write out y squared equals x plus 2. And to solve for y, we take the square root of both sides. So we could say y equals square root of x plus 2. No, be careful. This is a very dangerous bear trap. When you take the square root of something like, let's say, y squared, this is equal to absolute value y, which is equal to plus or minus y. Okay, so here I have to say plus or minus square root of x plus 2. So right away it's looking like, no, we cannot express this equation as a function of x. And the reason being is that we got a plus or minus here. And if I were to sketch this out, square root of x plus 2 is coming from the graph of square root x, except we're shifting it to the left 2 units. So we're going 1, 2 like this. But the plus minus means not only are we going to graph the top part of the square root, we're also going to sketch something down here like this. Okay, so let me just try to draw that a little bit neater. So we have this going this way. And notice that this is in the shape of a parabola. It's a y squared parabola. If I were to solve this equation for x, I could say x equals y squared minus 2. So when I see that equation, I just think of a different equation. I think of y equals x squared minus 2. I pretend that x and y are switched, and it reminds me of the parabola starting at 0, 0, but just shifted down 2 units. So it's kind of something very similar here, except it's facing sideways. So no, this would not work. And if I really wanted to be sure, I could throw in the vertical line test like this and show that it's hitting the graph at 2 locations, but we cannot express this equation here as a function of x. Question 3, we want to see if from this equation we could define y as a function of x. So let's start by trying to solve for y. And notice we have y terms on this part here and this part here. So if we factor out y, we get 3x minus 5y in parentheses, and this is equal to 4. And just looking at what we have right now, I could see that y is not going to be able to separate. We are not going to be able to solve for y. Some people might say, well, what if we divide both sides by y? Well, now what we have is we have 3x minus 5y equals 4 over y. And from here, notice we have y terms on the left and the right side. So even if we were to start separating and solving for this y term over here, we're still going to have a y term on the other side as well. We would have something like negative 5y equals 4 over y minus 3x. And then we could divide both sides by negative 5. But once again, even though we solved for the y term on the left side, there's still going to be a leftover y term on the right side. So this equation here is non-separable. And since we cannot solve for y, we cannot express this equation here. We cannot define y as a function of x. Now, one more thing before we move on. If we go on Desmos and we graph the equation from question 3, and let's say I draw in the line x equals negative 6, which is a vertical line going through the graph over here in this portion. Notice that the vertical line makes contact with the graph at 2 locations. So by the vertical line test, we could see that this graph cannot be expressed as a function of x. Question 4, we have y to the third equals x, and we want to see if we could define y as a function of x. So we could start by taking the cube root of both sides. So we're going to go cube root on the left and cube root on the right. And now we have y equals cube root x. And this here we can call a function of x. We can say f of x equals the cube root of x. And for this one, we aren't going to run into the same issues that we ran into earlier. Before, I said something like this. When we take the square root of y squared, we have to worry about this being the absolute value of y, which is plus or minus y. But here, this is not a problem this time around because we're taking an odd root. Okay, so this is something that we can solve for y, and we could express our function as f of x equals cube root of x. If we were to do a sketch here, we would have something that looks like this. So we would have the function going up like this, and then it's going to go this way, going into quadrant 3. And over here, we would have a vertical tangent, but that would be at the point 0, 0. This over here, the graph of cube root x, is a function of x. It passes the vertical line test at every location. So we could say yes for question 4. We could express this equation here, or the y we could express as a function of x. Question 5, we have this equation, and we want to see if we could express y as a function of x. So for this one, the algebra that we need to know is that when we do a to the b times a to the c, this is equal to a to the b plus c. So I want to use this rule, but I want to use it backwards. I'm going to apply it to this term over here. So we're going to have 1 equals x plus 5, and the stuff that I highlighted here, e to the y plus x, I'm going to break this up as e to the y times e to the x. So I'm just using this product rule for exponents, but I'm using it backwards. So from here, we want to solve for y. So I'm going to divide both sides by x plus 5 times e to the x. So I'm doing that on the right side, and I'm going to do that on the left side as well. On the right side, x plus 5 over x plus 5 cancels. E to the x over e to the x cancels. And now we have 1 over x plus 5 times e to the x is equal to e to the y. So now from here, our goal is to solve for y, and the opposite of e is natural log. So we're going to take the natural log of both sides. So we take the natural log of the left, and we take the natural log of the right. Over here, natural log and e just cancel out, and this is going to give us, we could say y equals natural log, and in parentheses here, we have 1 over x plus 5 times e to the x. Okay, so here is our function. And in a moment, I'm going to pull up a graph of this, but I'm going to say, yes, we could define y as a function of x. We could say f of x equals natural log of 1 over x plus 5 times e to the x. And a little extra detail here, one thing to point out is that natural log is only defined for positive terms. The inside would have to be positive. E to the x on its own, so e to the x, if I do a little sketch over here, is always positive. Okay, so that factor in the denominator over here, the e to the x, this piece is always positive. But if I'm looking for the domain, I could just look for when is x plus 5 positive, or when is x plus 5 greater than 0. And the domain would be x has to be greater than -5. So one more thing before we end. We have a graph of the equation from question 5. And I'm going to graph f of x equals, and I'm going to write in our solution. We had natural log, and then we had 1 over. And in the denominator, we had x plus 5 in parentheses being multiplied by e to the x power. And notice when I type this in that we get the exact same graph as the original equation from question 5. So our solution checks out. We could say yes, that we can express y as a function of x.